Unit 4 Chemistry, Chapter 11, Part 1. Here we're looking at the properties of some of these organic compounds we were looking at last time. So the first thing we're going to look at in this short video is the trends in the boiling points. So there's two things we need to consider. The first is what happens within a homologous series. And the second is what happens if we change the functional group. So within a homologous series, remember you've got the same functional groups, you've got the same chains with the same chain lengths, except for your main chain. If you go along a functional group, you are adding a CH2 to the main chain. Now a CH2 can only form dispersion bonds because it's nonpolar. But as you increase that chain length, you are adding more and more and more of those dispersion forces. And if you add more dispersion forces, then you need more energy in order to break them, which is what you are doing when you are boiling. So the bigger the molecule, the higher the boiling point. The other thing they depend on is the functional group. Now, if you have a polar functional group, then it can make a dipole-dipole interaction, which is of course stronger than a dispersion bond. If you have a very polar functional group, then you can probably also make hydrogen bonds. Okay? So things like your carboxylic acid groups are exceedingly polar. Your alkanols are polar. Your haloalkanes are polar but not as much. So the more polar the functional group, the stronger the intermolecular forces, and therefore the more energy you need to overcome them, and therefore the higher the boiling point. Okay? So here we can see our carboxylic acids, which have got the highest boiling points, and we can see that as we increase the number of carbons in the chain, it increases. The same trend as we go along a homologous series is seen for all of them, but we've got our alkanols, which are still polar, which are slightly less, and then down the bottom here is where we've got our non-polar ones, our alkanes, our alkenes, and our alkynes. The other trend we will see is in viscosity and flash point. Okay, viscosity is how thick it is. Flash point is what temperature it gets to before it just spontaneously bursts into flame. Okay? We will find that they have exactly the same trend. And the reason we get exactly the same trend is that we are still, for all of these, having to break intermolecular bonds. Okay? So if we are turning it into a gas and we are burning it, well then we still need to break those intermolecular bonds and the intramolecular ones. Okay? With viscosity, as a liquid is flowing, right, the stronger the bonds holding one molecule to the next, the more viscous it is, the thicker it is.